This is part 2 of section 3.2, measures of spread. These examples go with Chebyshev's inequality. Example 6. A group of elementary school students took a standardized reading test. The mean score was 70 and the standard deviation was 10. Someone says that only 50% of the students scored between 50 and 90. Is this possible? Okay, first of all, we can't use the empirical rule on this because we don't know that our data is actually normally distributed. So what I'm going to do first is I'm going to sketch a little number line down here, and I am going to label the mean right here in the middle, and I'm going to go 1 standard deviation to the right, and I'm going to go 1 standard deviation to the left, and then I'm going to go 2 standard deviations to the right, and 2 standard deviations to the left, and then I'm going to go 3 standard deviations to the right, and 3 standard deviations to the left. All right. According to Chebyshev's inequality, we can expect about 75% of the students to score between 50 and 90 on this test. And we can expect about 88.9% to score between 40 and 100. So our problem is asking us about the students between 50 and 90. And the person's making a claim that only 50% of the students scored within there. Well, according to Chebyshev, 75% of them should be in there. So this is not possible. The claim is not possible. Example 7. A certain type of bolt used in an aircraft must have a length between 122 and 128 millimeters in order to be acceptable. The manufacturing process produces bolts whose mean length is 125 millimeters with a standard deviation of 1 millimeter. Can you be sure that more than 85% of the bolts are acceptable? Well, we're not sure if our data is going to be normally distributed or not. I don't have a histogram and it doesn't tell me in the wording here. So we're going to have to treat this with Chebyshev's inequality. I'm going to draw a number line down here. And I'm going to put the mean length right here in the middle. And then I'm going to go to the right 1 standard deviation. And to the left 1 standard deviation. And to the right 2 standard deviations. And to the left 2 standard deviations. And to the right 3 standard deviations. And to the left 2 standard deviations. Now, according to Chebyshev, we know that there should be about 75% that fall in this range between 123 and 127. That's 2 standard deviations. And we also know that there should be about 88.9% that fall within 3 standard deviations, which is 122 to 128. Now our question is, right here, the length needs to be between 122 and 128 in order to be acceptable, and we want to make sure that there's more than 85%. Well, by using Chebyshev here, we get 88.9% between 122 and 128, so we can be sure that more than 85% of the bolts are acceptable. All right, and here is our conclusion. Yes, we can be sure that more than 85% of the bolts are acceptable, and it all has to do with the fact that we've got 88.9% between 122 and 128.